Hi everyone, my name is Pradyum Ramkumar. I'm happy to welcome you to the second episode of our CTO lectures. Today's topic is rethinking in-building cellular connectivity for modern enterprises. I'd like to welcome Mehmet to this conversation.
It's my pleasure to be talking on this exciting episode of the CTO lecture series. I'm the co-founder and CTO of Celona, and at Celona my focus is defining the technology vision for our innovative end-to-end 5G networking solutions for enterprises. And I've been in the wireless communications for almost 30 years, and previously I served as the CTO of Ruckus Wireless, and before that I was the VP of Engineering at Qualcomm Corporate R&D. And today we have this very interesting topic, at least for many of us, which is the in-building cellular connectivity for the enterprises. So I will just dive into it. And it's, first of all, like, why are we talking about this, right? And the motivation is, it's very well established that about 70 to 80% of cellular traffic is consumed indoors. So indoor cellular coverage is a very important topic. And we'll dive into these details today, right? First, we'll start with why indoor coverage is a challenge. As operators continue to deploy 5G macro cellular networks, indoor coverage should be better, right? Well, actually, it's not the case. Indoor coverage continues to be a challenge. Then we'll get into why do enterprises care. We will share some of the survey results we have done with a large number of enterprises that goes into the pain points about cellular connectivity. Then we'll dive into what are the key aspects that enterprises care about for in-building coverage, from total cost of ownership to the speed of deployment to performance aspects to emergency services. We'll cover those topics. And then in the last section, we'll dive into the solution space for indoor cellular coverage. And we'll discuss the evolution of indoor cellular technologies. I'll discuss different solutions such as Wi-Fi calling, repeater systems, distributed antenna systems, small cells, and of course, neutral host solution with MACN architecture. I'll cover the pros and cons of each of these technologies and compare and contrast them. So, okay, let's dive into it. Now we are in 2025 and mobile networks have been deployed over many years and 5G is in full stream, and we still have indoor coverage issues. Why is it still a challenge, right? Actually, there was a recent study showing that indoor cellular coverage is getting worse over the years. And there are multiple reasons for this. First is buildings are, especially enterprise buildings, are becoming more and more energy efficient. The materials used, such as LEED certified building materials, the E-rated glasses, really block the RF signal. So it is even harder to penetrate inside the buildings with these energy efficient buildings. Secondly, the 5G technology typically uses the mid-band frequencies, right, from 3.5 to maybe 4.5 gigahertz range. And the signals at those RF frequencies really struggle in terms of penetrating towards the buildings compared to the earlier, 3G, 4G technologies where lower frequency bands were used. And adding macro cell towers are costly and it takes years. So operators are really struggling to add more cellular towers. So indoor cellular coverage is not really getting better. And the next question, I guess, is why do enterprises really care about this? So let's cover that a little bit. We've been talking a lot of enterprises across many verticals, from so-called carpeted enterprises to more industrial enterprises, and many of them tell us indoor cellular coverage is a big challenge. In fact, we have run a survey with a very large number of enterprises recently, and here I'm sharing some of the results. These survey results show us that nearly half of the respondents report moderate to severe indoor coverage issues. Then our next question for these enterprises was, what is the business impact of this poor cellular coverage? So in other words, why do they even care? And here I'm showing some of the top reasons where the survey respondents gave us. The first one is lack of reliable coverage in the key operational areas. We heard poor connectivity impacting productivity. We heard about drop calls and unreliable voice communications. And if you talk to them about some of the details, they will tell us things such as, well, when my sales team is on a call with a potential customer and a call drops, it's a big deal. Or engineers and workers not being able to communicate with each other or with their vendors, it's an issue. Sometimes workforce cannot even talk to their families. We heard from some of the respondents that they may have some loved one or maybe wife pregnant, and the person at work is really worried if his wife cannot call him and reach him. Or sometimes E911 availability is a concern. Also, inconsistent Wi-Fi calling experience is something we hear a lot. So this is because some enterprises tried Wi-Fi and their experience is usually not consistent and not reliable. Also, enterprises using IoT and smart devices have difficulties in connecting those devices indoors. So the other aspect here is what type of verticals complain most about indoor cellular coverage. And here I'd like to give some of the insight on that. First one is the healthcare, right? In the healthcare, we see that the cellular coverage requirement is mainly driven by doctors, nurses, patients, and visitors. For example, when a physician's phone doesn't work, it's a big deal. Or when you're in a waiting room and anxious about the loved one who may be inside the hospital and you cannot connect to others, it is a big concern. In the retail space, we see a lot of demand as well, as many of these retailers start enabling self-checkouts, like scan and go kind of applications. They need reliable connectivity for the customers. Also, many industrial customers have deployed private 5G, and now they're asking us, how about public cellular connectivity for their employees? For example, think about an engineer on the shop floor needing to call a vendor or a supplier. His or her phone needs to work. We also need a lot of demand from commercial buildings with offices and more traditional type of workspaces. And here the workforce also needs a reliable connectivity as well. So it's clear that these enterprises need reliable connectivity, but what are the critical aspects for them? What are their key requirements? So next we'll go into that. So here we'll talk about some of the key themes one by one. Of course, the one key requirement is the cost of the solution, right? In the old days, MNOs would subsidize the cost of indoor solutions, and nowadays that's very rare. Typically, enterprises need to pay for it. And enterprises have limited budget and may not even have dedicated budget for indoor cellular. So when they look at the cost, they look at the total cost of ownership, and that becomes an important aspect for them. Second aspect is how long would it take for the solution to be deployed and operational? Many times we hear that enterprises which experienced DAS took a long time. Even after they installed the DAS, then enterprises need to negotiate with each operator individually and sign contracts with one by one, and these negotiations and contracts can literally take multiple years. Meanwhile, enterprises are stuck with very poor cellular connectivity. And the third one is the upgradeability, right? Enterprises can have many employees and they need capacity and performance. And even if you can have some basic connectivity, many times that's not sufficient. For example, the cellular repeater solutions, they simply boost the signal strength, but they don't really provide any additional capacity. So even for everyone in the building, when they have like full bar on the devices, they may have very little throughput, a few megabits per second kind of throughput on their devices. Also, some enterprises may get a 4G solution today, and if it is not upgradable to 5G, that's a concern. Another important aspect is the support for E911 and emergency services, and this becomes very important for many enterprises, including higher education. Solutions like Wi-Fi calling typically won't support E911 or wireless emergency alerts. Another one is providing coverage in the areas that they really need, right? So enterprise may have coverage issues in certain areas of a building. For example, the coverage issue may be only in the basement of a building, and the size of the buildings can vary significantly from very large buildings to small offices or branch offices. And typically solutions like DAS, distributed antenna systems, require significant capital investment and may require the whole building to be installed with many radios. So those solutions may not be feasible for medium-sized or smaller buildings. And lastly, many times we hear from the enterprises uh, the need for visibility on how the system performs. For example, with DAS or repeater solutions, enterprises will not have any visibility on how many users are connected to the network and how is their user experience is. So these are the different dimensions that we look at enterprise solutions. And I like to kind of keep this up there for a second so that folks can really absorb it. Because next we'll dive into the solution space and look at each different solution and how do they perform in these different dimensions. Okay. So as I mentioned, there are quite a bit of solutions in the indoor cellular space, and these solutions have been evolving over the years. And each has some pros and cons. And in this section, we'll cover each solution and evaluate them in these dimensions that I described earlier. So the first one is repeater DAS. Like, what is repeater DAS? Basically, in these systems, there is typically a donor antenna on the rooftop, which collects the macro signal, you can call it, and then it goes through an amplifier and distributes the signal through remote antennas inside the building. So these solutions are, in terms of affordability, they are moderately affordable, I would say. You will see on the chart now these different attributes, because you still need to invest in additional cabling. You need to put these donor antennas on the rooftop for each operator. And the other aspect is in terms of how long it takes for these solutions. These installations can take a significant amount of time. And the donor antennas needs to be dependent for each of the frequency bands and the operators. So there's some dependency on the operators. But one good aspect of it is, here, I don't know if you can see my cursor. I'm going through this list here. The contract setup is not that big of a deal in this, because you're basically repeating their signal. The capacity is a big concern, though, because in terms of capacity, it is the whole building essentially connecting to the same macro base station tower and sharing that capacity with the whole vicinity in that neighborhood. So these solutions, although they amplify the signal strength, doesn't really provide additional capacity. But in terms of reliability, mobility, voice quality, they provide good performance. And most of these solutions are 4G today, but their upgradeability to 5G is usually a challenge because these systems are typically FDD, and most of the 5G technologies are TDD, if you look at the deployments in US and elsewhere. So the 5G upgradeability is typically an issue. E911 and emergency alerts are fully supported in these systems, but it doesn't provide visibility to the enterprise. So an enterprise IT wouldn't know how many users are connected, how is their experience. There wouldn't be any of those dashboards and so forth. And it will have significant footprint, right? For all these infrastructure, for the donor antennas and the amplifiers, splitters, cabling, and the remote antenna units. So all those will add significant footprint. Okay, next we'll talk about traditional DAS, traditional distributed antenna systems, or current evolution is typically called multi-operator RAN or MORAN. In these solutions, typically each MNO brings their own backhaul to the building. As you can see on the left bottom, that backhaul connects to their core, and then they bring their own baseband equipment, which is that blue box on the bottom, and that baseband equipment is connected to an head-end unit. And then from that head-end unit, you'll typically have fiber connectivity to each floor of the building to distribute the signal. And each floor, you will have a gateway or a remote head connecting the signal to each of the remote antennas on the floor. So these deployments are typically quite costly because of the installation cost and all the labor and the equipment cost, such as the base station on the bottom, on the basement of the building, and all the infrastructure, cabling infrastructure and antennas that needs to be installed. And typically these deployments take quite a bit of time from the start to the end of the installation. Additionally, there needs to be contracts with the operators, so there's quite a bit of a dependency there. There needs to be separate contract with each one of the operator. Each operator needs to then bring their signal source, and that dependency and contract setup is usually a big pain point. On the bright side, these solutions typically have reasonable capacity, reliability, mobility, and voice quality is very good. The solution can be upgraded to 5G as long as the base station equipment, this operator radio equipment, is upgraded to 5G, and it supports all the emergency services such as E911 and wireless emergency alerts and so forth. But on the visibility side, there is hardly any visibility. The enterprise IT, similar to repeater DAS solutions, have very poor visibility, and there will be a lot of equipment footprint. All these equipments that I mentioned require a lot of real estate space from the enterprise. Next, we'll talk about Wi-Fi calling. Of course, many enterprises, almost all the enterprises have Wi-Fi installed, and there is a way to connect your voice calls through the Wi-Fi, which is called typically Wi-Fi calling, where the devices connecting to the Wi-Fi APs, the voice traffic can be carried over the local enterprise network over the router to the internet, and from there, the traffic is connected to the operator core. So that solution is used in some of the enterprises because it's typically affordable. It doesn't require additional installations. It's basically additional functionality of Wi-Fi, and time to enable these solutions can be quite small. So those are the advantages. But unfortunately, there are still some dependencies to the operators because the backhaul needs to be connected to the operator core network, and certain firewalls needs to be enabled. And typically what we hear is that those operator core IP addresses may change, so enterprise firewall needs to be adjusted. Or if it's a retail store and the customers walking in the store are not connected to the Wi-Fi, they wouldn't benefit from this solution. So there is some operator dependency for those solutions. In terms of capacity, as long as it's a good quality, high quality Wi-Fi solution, capacity can be quite good. But usually the reliability and mobility and voice quality is moderate, sometimes very poor. It will depend on how much the load is there on the Wi-Fi network, and there's typically no QoS on the Wi-Fi network, so we hear a lot about quality issues. The 5G upgradeability doesn't really apply for the Wi-Fi solutions, and typically 911 and emergency alerts are not supported. So those are some of the issues. On the visibility side, the IT or the enterprise networking groups will have some visibility to the Wi-Fi network, and the footprint will have a very small requirement because, again, enterprises already have these Wi-Fi deployments in place. All right. So if we move on, the next one we'll talk about is the small cells. So in this deployment model for indoor coverage, each operator brings their own small cell. So here what we are showing is 3 different operators. They have their own dedicated backhaul coming to the enterprise, and inside the enterprise, each operator needs to have their own small cells or access points. And these access points can be integrated to the local area network or maybe separately cabled. But as I showed here with different colors, the point is each operator has their own small cells. And this kind of brings some complications to these deployments. In terms of affordability, typically enterprises get these things provided from the operators, but it is less and less likely that operators will bring these solutions to the enterprises. And if they do, bringing this solution, installing everything, there's a lot of dependency. It may take a significant amount of time. There is separate contracts that needs to be in place with the operators. So those are the challenges, right? In terms of capacity, reliability, seamless mobility, voice quality, these solutions usually are very good. And the small cells may be 5G capable or maybe upgradable. So there's a path for 5G upgrade in these solutions. They, of course, support the E911 and emergency alerts. But again, there is almost no visibility from the enterprise side in terms of the usage, in terms of how many users are connecting, what is their experience, and there is a significant equipment footprint in this solution because each of the operators require their own equipment to be installed. All right, so the last and the most exciting one, which is a newer solution, is the multi-operator core network-based neutral host solutions. And this is the evolution of the indoor solution with the latest and greatest, I would say. And in these solutions, basically, what you have is somewhat similar to a Wi-Fi installation, where you have these local access points inside the building connected to the LAN using the existing infrastructure, and using the existing router, they access to the internet. But then in this case, it goes through the so-called MACN gateway. In this picture, we are showing the Celona solution, Celona Multi-Operator Exchange Network Gateway, which connects the network to the operator core. So the key aspect here is that the solution provides the operator signal inside the building. So it is broadcasted inside the building, but multiple operators are broadcasted from the same access points inside the building, and it leverages existing backhaul of the enterprise to access to the internet and operators core. So in terms of performance of this, the affordability and time to air is usually very good because this installation requires only these 5G access points to be deployed, and it is one radio, one access point for multiple operators. So that's a big benefit. And there is typically no MNO dependency because, for example, at Celona, when we provide the solution, we already take care of all the MNO contracts and all the backend work. So no separate contracts needs to be negotiated with the operators. The capacity, reliability, mobility, voice quality, all of those are excellent in this case because each of these access points is essentially a base station, a small base station providing a lot of capacity, capability. And the technology is cellular technology, right? So it is actual 4G or 5G signal. The 5G upgradeability is certainly possible. For example, at Celona, our access points are both 4G, 5G capable. The E911, all the emergency services, emergency alerts, and wireless priority services, all of those are supported. And this solution gives full visibility to the enterprise in terms of the usage of the network. And the equipment footprint is usually very low. What we typically do is when we deploy an access point, we can cover an area of 4 or 5 Wi-Fi access points. So one neutral host access point will cover 4 or 5 times the coverage area of a Wi-Fi. So you typically have very few access points needed to cover a given area. And the footprint is low because of that. And it leverages many times the existing switches and the routers. So there's no additional equipment needed for that. So to bring all of these together, I'm showing the landscape here. It is an eye chart. There is a lot of different dimensions here. Again, there is a repeater DAS, traditional DAS or MORAN, Wi-Fi calling, small cells, and the MACN-based neutral host. And you can see different dimensions in terms of cost and MNO dependencies, performance, and 5G upgradeability and emergency. So for all these dimensions, when you look at it, we see a significant benefit of the MACN solution. And that's why we have been seeing a lot of traction in the field so far. And just to share with you our solution, this is our Celona neutral host MACN solution. And we recently commercialized this with the architecture that I described earlier. And our commercial solution has been deployed in many commercial settings, such as hospitals, retail stores, universities, office buildings, and manufacturing factories. We see a lot of demand for our solution because we can enable these deployments very fast, typically in 48 weeks. Our deployments are typically a fraction of the cost of traditional distributed antenna solutions. And our customers generally choose to start small in a few buildings or maybe a few floors. It may be a basement. Then they expand to more buildings. So it can enable that slow start and expansion for the technology. And at Celona, we are also very proud to have this unique offering where our radios support both 4G and 5G. So we can also provide private 5G in addition to neutral host service using the same infrastructure without adding any additional hardware. And lastly, we can handle all the contractual obligations with the MNOs, so our customers and partners don't need to worry about those lengthy contracts with each of the MNOs. So that concludes our session, and here maybe I'll pass it back to you, Pradyum.
Thank you, Mehmet. It was a wonderful presentation on in-building solutions. So we have a ton of resources on the Celona website. The first place to look at is the Celona neutral host website, where we talk about why neutral host is an ideal solution for in-building. We talk about the simplicity of Celona solution. So please go consume the resources over there. We have a big focus in healthcare, and we created a healthcare website. And in this healthcare website, you can actually see live performance data as one of our solution architects walks inside the building. He has measurements of what the MNO signal is versus what neutral host signal is. Also, we have Stanford Healthcare, who is a big customer of ours, giving their testimonials on this site. And last but not the least, we've been doing this CTO lectures. This is the second lecture, as we all said. And we deep dive into some technology topics, and all that stuff is on the CTO Lectures website. So do check it out, and you can actually keep looking at it as we add more episodes month on month. So with that, that comes to the conclusion of our CTO Lectures today. Thank you, Mehmet, for your great participation, and thank you all for watching this video. If you want to talk about neutral host or private 5G, please definitely contact us at cellular.io/contact. Thank you.
Thank you, everyone. Looking forward to our next session together. Bye.